Okay, guys, good afternoon. So let's see what the question entails. Let's see what we can do. So we are asked to, the question is given as R1 X or R2, okay, minus bracket open R2 X nor, okay, R1. Okay, so this is the question. Please, this is no, X nor R1. Now, before we further, let me explain what XOR is. I have done this before, but let me recap it again. I will explain what XOR is. I will explain what XNOR is. Okay? Now, in terms of XOR and X whatever, XOR is a function that is only true. It gives you a true, that is 1, when you have different inputs. For example, you have 0 and 1, A and B. It will give you a 1. It will give you the output 1 in XOR. It will give you the output 1 when the inputs differs. But when the inputs are the same, for example 0, 0, it gives you a 0. When the inputs are 0, 1, 1, it gives you a 0. Now if it is 0, 1, 1, 0, it gives you a 1 and 1. Why? The input differs. But when the inputs are the same, it gives you a 0. That is XOR. Now that is for XOR. Now for XNOR. XNOR is the opposite of this one. Meaning if you have two inputs, this and this, 1 and 0, when they are not the same, it gives you a 0. But when they are the same, it gives you a 1. That is for XOR. When they are the same, it gives you a 1. When they are not the same, it gives you a 0. When they are not the same, it gives you a 0 for XNOR. But for XOR, exclusive OR says when they are the same, it gives you a 0 instead. When they are not the same, it gives you a 1 instead. But this one says exclusive NOR gate says when the functions, the inputs of the functions given are the same. When they are the same, it gives you a 1. But when they are not the same, it gives you a 0. Is that clear? Is that clear? Now using this method, let us solve for what we are given. Now from the equation, we are told that from the equation that the value of R1 is given as 28 and the value of R2 is given as 20. Right? This is a question, the complete question. Now, what are you supposed to do? What are you supposed to do? You change this one from the decimal state to a binary function. Now, the binary function of this man becomes, don't forget your rule. When we have 1, we have 2, we have 4, we have 8, and we have 16. Let's use 16 bits. Okay? So from here now, how can we derive 24? So, 28. This plus this is already 24. So this one is on, 24. Plus this gives us 28. That means this one becomes 0. Automatically. This was not given, but I just derived it because it is the binary. This is a binary state of this number as the decimal. This is the decimal state of this number as the binary. Okay, so for this one, for 20, that means you need 16 plus what will give us 20. 16 plus 8 will give us 24, which is away. So we put 0 here. 16 plus 4. Look at 4 on top. This place is called for bit 4. Okay, so plus 4 will give us 20. That means this one becomes 0. Are we cleared? Are we cleared? Now, what is the next thing you need to do? This is a house. So from this house, you need to separate this one. You need to find this one first before we now find this one. After we should subtract this from this. So let's see. I said you'll find this one first, this house, this building first, before you form this building first. After we should subtract this from this. By subtracting this from this, you have to find the 2's complement of this, right? Let's see how it goes. So when we have R1x or R2, when we have this function, it gives us, don't forget the rule for XOR. XOR says when they are the same, it gives you a 0. I have stated that before. When they are not the same, it gives you a 1. When they are the same, whether it is 1 and 1 or 0 and 0, it gives you a 0. But when they are not the same, it gives you a 1. So 0 and 0 gives me what? A 0, because they are the same. 0 and 0 gives me what? A 0, because they are the same. For exclusive OR, exclusive OR, exclusive OR gate, this is what it's stated. I said that here. No, look at what I did. For exclusive OR, when they are the same, it gives me a 1. When they are the same, it gives me a 1. But when they are not the same, it gives me a 0. So I'm done with this one. Look at that there. Now, for exclusive NOR gate, when we had R2 exclusive, exclusive NOR R1. That's from the equation. R2 xnor R1. I said that this one, xnor, is the opposite of xor. Xnor is the opposite of xor. Xnor is the opposite of xor. Xnor is the opposite of xor. So from here, I can now come here, and when it is 0 here, it should be what here? 1. When it is 1, it should be what here? 0. When it is 0, it should be 1, 1, 1. If you don't want to use that method, you now say that exclusive NOR is a function that is derivable or that produces a 1. XNOR is a function that produces, XOR is a function that produces a 1. XNOR is a function that produces a 1. When you have that this and this given, when the inputs are the same, when the inputs are the same in XOR, when the inputs are the same in XNOR, when the inputs are the same in XNOR, it gives you a 1. Indirectly, I said the opposite of this XOR gives you the XNOR. The opposite of XOR gives you XNOR. But the function states that when the inputs are the same, it gives you a 1. But when the input differs, it gives you a 0, 1, 1, and 1. Okay, so you see now you can just take the inverse of this man and it gives you whatever thing you want to do. Okay, please, if you don't understand it, you can listen to this video again. Listen to it again for your own benefit. Okay, so we've gotten this. We've gotten this man as this. We've gotten this man as this. Now, if you check this work, you see that this is equals to 8 as the binary function. Look at now, this is 8. But this is the decimal function of this form. So the decimal function of this form is 16 plus 4, 20. 20 plus 2, 22 plus 1, 23. So we have 23 here. But this is a minus 23 because of this 1 here. This is a minus 20 because of the 1. This is a minus because of the 1. But if you don't want to go through it that way, you need to form the 2's complement of this negative number. Find the 2's complement of this negative number. Find the 2's complement of this negative number. Let's see it first. Now the 2's complement of this number, of this one, the 2's complement of this one, of R2 x nor R1 will give me 1, 0, 1, 1. I want to find the 2's complement now. Okay, let's see the 2's complement says convert it to 1's complement first. So the 1's complement of this function becomes 0, 1, 0, 0, 0, right? This gives you the 1's complement. Now, finding the 2's complement means add 1 to it. Add 1 to the 1's complement. That gives you the 2's complement. So 0 plus 1 gives you 1. 0 comes down. 0 comes down. 1 comes here. And 0 comes here. Are we clear? You can listen to it again to really understand what I'm saying. Now, after which, what are you supposed to do now? Take this man now. Add it to this one. Add it to the R1 exclusive or R2. Now the function of R1 exclusive or R2 is given as what? So we have that R1 exclusive or R2 gives me 0, 1, 0, 0, 0, right? Now the negation of this man, the 2's complement of this man, sorry, the 2's complement of this one, okay, which came as a result of this minus sign, giving me what? 1 negation of, sorry, that is 0. This 2's complement, result of this one, the result of this one gives me this from the 2's complement. So this is now the 2's complement. These are the 2's complement. Bring the 2's complement, add it to the first value, which is this one, right? So this is 0, 1, 0, 0, 1 comes down, right? Okay. So we've gotten this. Now we add it together. This plus this. This plus this gives me a 1. 0 comes here. 0 comes here. This plus this gives me a 0. Carry 1. Put here. This gives me a 1. Right? Okay. Now, does this give me what I want? Let's see this one now. We have that this is 1, 2, 4, 8, 16. So this is 16 plus 1 gives me a 17, which is not what I want. If you do this minus this, that is 8 minus 23 will give me equals to minus 15. So it's not what I want. So this is wrong. This is automatically wrong, right? Okay. So we're not going to take that one. Instead, we're going to do what? Find the 2's complement again. So the 2's complement on this one becomes what? 0, 1, 1, 1, 0, right? Add 1 to it. Let's see. Add 1 to it. Let's see. 0 plus 1 gives me a 1. 1 comes down. 1 comes down. 1 comes down. 0 comes here. Right? Okay. So let's see what it will give us. Minus 15. If you don't give a minus 15, that means we are wrong. So you have to check it again. So let's see. This is 1. That is 1. 1 plus 2. Sorry. Let me start from the side. 8 plus 4. 12. 12 plus 2. 14. 14 plus 1. 15. So we have 15 here. Just add your minus sign to it and you're done. Okay? And you say something that the lecturer told you. If you say something like this, just put one here and you float it, right? If you want to do it that way, you are free. If you don't want to do it that way, please, if you add your minus sign here alone, it changes this man to a negative number. Okay? So look at it again from the beginning. Look at it very well. Study it. Ask questions if you don't understand. This gives us that becomes that R1 exclusive or R2 minus R2 exclusive nor R1 equals to this. Final answer.